Alright guys, this is for after the test and or Tuesday night, okay? So, we're going to start learning about these quadratics as far as graphing them. This U shape is going to be called a parabola, or as I like to say, parabola. You're going to get your future math teachers mad if you say parabola, but it's called parabola. Where's the vertex? Guys, that's that valley right here, okay? That's 0, 0, or at the origin. Sometimes it could be upside down, but we'll get into that later. So, here's my function. If you were to plug this in your graphing calculator, or not your graphing calculator, but the Casio or whatnot, you would get out 41014. Because remember, if you're plugging this in, make your substitution. So let's put in -2. -2 squared is 4. Okay? Here's the points that associate with it. And we get this curve. I'm going to put arrows on here because it's going to go up to infinity. But notice how the values on the outputs, 41014, that shows you where that curve is. Okay? You also need you to understand that this, here let me use arrows. This graph, this equation, and this table are all one and the same. Okay? We need to be fluent as far as jumping from one to the other. Okay? How could you describe the symmetry of this graph? Well, right down the middle, y-axis. The vertical lines are going to be x equals something, in this case 0. Notice it goes through the vertex. Okay? Symmetry is always through the vertex. Let's keep going. What if we add 1 to it? So go ahead and take a second, fill in the chart. Remember, you probably want your whiteboards with the graph on the back of them. Fill in your chart, get your points, and then boom, you get 52125. Adding 1, what happened? From this one to this parabola, from blue to red, what happened? That's right, it went up 1 unit, up 1 unit. That's what happens when you add a constant of 1. Well, if going up is just adding a constant of 1, what do you think going down is going to do? -2. Okay, go ahead and plug in your points. Again, you're plugging this in like this. X squared minus 2, plug in the -2. Squared minus 2, that's 4 minus 2 equals 2. Look, I got 1 for you. Here's the rest of them. That's right. It went down 2 units. So, it's safe to say that your constants control the graph going up and down. Okay? Let's keep going. Here's your notes, but guys, trust me, I have a handout for you that sums all of this up. But if you want to write this down, you can. So notice it's going to be denoted with K. If K units up, the K is going to be positive. K units down, the K is negative. That makes sense because up is positive and down is negative. Okay? Alright, let's move on. Let's see here. Plus 2. What do you think is going to happen here? Before we were saying going up and down 2. Let's figure out what's going to happen now. Go ahead and take the time to plug in your values. So -4 plus 2 is going to be -2 squared. We get 4. Okay, and this is our parent function in blue. It's not going to move. Get your points. Look what happened. Did you think it was going to shift to the left? I mean, it's a +2 after all. That's what happens. Strange things happen in these parentheses. If we were to finish it off, connect your dots. Moves to the left. Now I know that's against what you think, but the only way I remember is strange things happen in parentheses, okay? Well, if positive sends it to the left, what do you think a negative is going to do? Go ahead and take some time, pause the video, Plug these values in. Okay, your result should be 41014. See where the dots are now? So our rule of thumb now is negatives, make it go to the right. Now notice where it's at. It's in the parentheses. Look back at this one. It's in the parentheses. Before, the constants were outside. Do you see that? Look up here. So now they're with the x's in the parentheses, and that's what's causing them to shift horizontally left and right. But it's always going to be the opposite. So our rule of thumb here, f of x, x minus h. H is now going to control the horizontal shift. We'll shift parabolas horizontally. Notice that there is a minus sign between the x and the h. That means the graph will move h units right if you see a negative number, and h units left if you see a positive number. Okay, opposite. You gotta think opposite here. Why is this strange? Well, because strange things happen inside parentheses. Okay, this is super important. This happens all the time. You got to think opposite when you have parentheses. Okay, write this down if you haven't done so already. All right, moving on. So write the equations for each of these graphs. Again, think your parent function, right? Ooh, okay, that was a little weird. But think about it. It's shifting to the right, so this should be y equals, that's right, x minus 1 because of strange things. Again, if your parent function's about here, it's shifted down, so what should this equation be? That's right, x squared minus 4. Notice the difference here. Again, I'm going to have a cutout that's going to sum all this up for you, okay? Let's keep going. This one shifted to the left. Good, and I think you're getting it. So x plus 2, opposite. This one went up 1, so y equals x squared plus 1. Let's combine them now. Remember, your parent function right here. Sorry for the audio. Look at these two vertices. This is where I'm kind of matching them. I go over 1, go down 2. So let's do the parentheses first. X, I shifted to the right, so subtract 1 squared, and I shifted down, minus 2. Okay? You got to get this stuff down, because you can graph quadratics a whole lot easier using this method if you get your shifts down correctly. So describe transformations for each parabola based on its equation. Go ahead and pause the video, try to work these out. Alright, if you came back, here's your answers. This one shifted down 3 because of that constant negative 3. Shifted 3 to the right because strange things happen in parentheses. Shifted up because of the positive 3 constant. Shifted 3 to the left because, again, strange things in parentheses. And this is a combination. To the right 3 and up 3. Okay? Now just go ahead and ignore this. We'll show you what we're going to be doing. These 6 problems, okay? You're going to graph them and talk about their shifts. Okay? So, for this one, and notice there's a handout that looks just like this, so you can practice these things. Or you can just use the expo and the whiteboard. So, x minus 2 squared plus 6. Let's see here. Let's work the shifts. That's a shift to the right by 2 units. Strange things. and then that's up 6 units. So up 6 units. Boom. Now, as far as where to start on your T chart. Your T chart, I know where my vertices is. Okay? These are your big hints right here. Okay, it's going to be 2 and 6 is where my vertices are. Now, going back to that idea with the pattern, how you see the curve, I'm going to pick 2 points above it and below it. And then I'm going to plug them in, okay? So if I plug in a 1 right here, 1 minus 2 is going to be a negative 1. Negative 1 squared is 1. 1 plus 6 is 7. Plug in a 0. Negative 2 squared is 4. 4 plus 6 is 10. Plug in the 3. 1 squared. Look at that. That's 7. See how it curved? 6, 7. And we're going to keep up the pattern. So go ahead and plot your points. 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 7. 1, 2, 3, 4, 5, 6, 7. And 2, 6. 1, 2, 3, 4, 5, 6. Look, I know it's going to reflect the exact same because that was our line of symmetry right down the middle here. Now you don't need to do that. I was just reminding you about the symmetry, so I'm just going to use that to my full advantage. But hey, I can still plot these. So 4, 10. So 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know it's going to curve up or open up. Boom. Job done. Now, let's say I'm still not seeing these graphs. I don't know how to graph. Take this and go to Desmos. Okay, here's Desmos. Desmos, just type it in. You can search it. It'll pop up. And you can plug these things in. So parentheses x minus 2 parentheses squared plus 6. And lo and behold, 2, 6 was my vertices. And you can see, see how it pops up that little point counter thingy. So, play around with that so you can get the idea of what it should be. Whoa. Anyway, so you can be doing that for all of these. Now the fact that I showed you, oh, that's not yours. Oh, that's not yours either. The fact that I showed you that, you can work these out on your own. Now, that negative 2, we're going to get into that. This is going to reflect, which means it opens down, and it's going to stretch. We'll talk about that on the next slide, okay? But for right now, you can use Desmos to help you out. Get your T-chart. For this one example, my vertices I know will be negative 1, 3, just to get you started. And just worry about these shifts. That's all I worry about right now, okay? Same thing, just worry about the shifts. And again, the vertices for this one will be 3, negative 12. So 2, 1, 4, 5 to get you going. 6, so 6, 3, 5, and 4, 7, 8. Again, you can plug these in. Use Desmos to check. And this one will be 3, negative 4, so 2, 1, 4, 5. This one, 3, negative 3, 2, 1, 4, 5. So go ahead and practice graphing these things. Let me check my time. Alright. I'm going to go ahead and move on to the next thing. Okay? Ideally, so you know where to put these cheat sheets that you're getting tomorrow. I mean today. Alright, I'm recording this yesterday. You're hearing it today. Hopefully. Alright. I'm about to burp. Excuse me. So, real quick. Shifts. Right. Let me get my markers. This one's going to be right. Right 1. And up 2. And yeah, I shorthanded that. Write 1. Write an equation for the graph below. Again, parent function is right here. So it looked like we shifted to the left. And then we went down 1. Down 1. Shifted to the left. 3. Remember opposite. So y equals parentheses x plus 3 squared minus 1. All right, moving on. And we got the right answers. So, how can you graph the quadratic function? That's what we're dealing with. Shape of a quadratic function, remember, is a parabola. Now, I'm plugging in a negative now, okay? Okay? So if you plug this in, watch this. Negative x squared, notice there's no parentheses. So I'm going to plug in a negative 2 where the x is. There's a negative out front, squared. Negative 2 squared is 4, but you got to bring down that negative and it turns into a negative 4. That works for all of them. Look what happens. All your values turn negative. Your parabola is upside down now. This is called a reflection, okay? What kind of transformation is this? Reflection. I talked about this in coordinate algebra. Okay? That's just because of the negative out front. So if it's a positive, it opens up. If it's a negative, it opens down. And again, I got a cheat sheet for all of this. Now, what happens if you put a 3 in? Well, again, plug it in your calculator. You'll get these points. You'll notice the graph kind of squeezes in. We're going to call this a stretch. Stretch. Stretch, stretch, stretch. Sorry, I had to go open the door. All right, this is going to be a stretch. Okay? Now, think of it as like silly putty. I don't know if you've ever done it, but I would stick silly putty on newspapers, peel the ink off, and then pull the silly putty and the image just stretch. Kind of the same principle, okay? Now, if that's the case, what do you think this half is going to do? Go ahead and try it out, graph it. Here's your coordinates. It gets wider. We call this shrink. Okay? Kind of like if you were being pressed down, you, I don't know, you just get taller or you get squashed. But you shrink. Compresses it, might be the best way to say that. So, if A, we're looking at A, the coefficient is greater than 1, it stretches up. A, if it's between 0 and 1, notice I'm not talking about negative, I'm talking about fractions. It shrinks down, it gets wider. Okay? If it helps, you put wider here, taller, just whichever word you want to use, but you got to be familiar with it. So, I know you'll have this page today. You can add it to page 26 if you get the chance. Sorry, I'm on the phone. Hold on. All right, I'm back. Sorry for the interruptions. Anyway, here you have this handout. Again, I think it's on page 26. Maybe, maybe not. I don't know. I think we were down 1. Did y'all say it was 25? Okay, I'm not sure. Anyway, quadratic transformations reflect if there's a negative. Okay, so positive opens up, negative opens down. Go ahead and add these things for the sake of future references. Horizontal shift. If it's plus, you go left. If it's right, excuse me, if it's negative, it's right. Positive for vertical shift is up, negative is down. Stretch. If A is greater than 1, it's a stretch. And if it's 0 to 1, it's a shrink. You know your fractions. Go ahead, add all these notes, because you're going to need them. All right, moving on. So, functions below, identify the vertex, axis of symmetry, and transformations. Go ahead and pause the video, give it a shot. All right, here's your answers. Reflects down because of the negative. Stretch because of positive 3. Not a positive 3, but I mean the 3 is greater than 1. That's what causes the stretch. Shift up 2. This one, a shrink, because that's a half, which is less than 1. A right by 3, because it's negative 3. Shift left 4, because of positive 4. Down 1, because of the negative 1 for a constant. 3/4 is less than 1, so we have a shrink. Shift up 3, because of positive 3. Stretch, because of the coefficient is greater than 1, which is a 3. So we have a stretch there. Shift up 4, positive 4 there, the constant. And we shift to the right because of the negative 1. Reflect down again because of the negative. And shift down 14. We went down 14. Okay? Add this to your handout, or put this in your composition book. Let me see if I got this on the next page. Nope. Add this to your composition book. I think we're running out of time, but ideally we're going to work through this when I see y'all again. Okay? You'll put this on the next page. Like if that last one was on, can't write page. We're going to put this in the composition book on page, I don't know, if the last one was 25, put on the very next one, 26. Okay? Or if that last one was 26, put on 27. Welcome to my life. What am I drawing? An eyeball, maybe? Look at that. Y'all didn't think I knew how to draw, didn't you? Look at them pretty white teeth. Oh, this guy's pretty creepy. Oh, this is a disaster. All right. We'll see y'all tomorrow. Bye. All right, I'm done here. All right, good night.